Okay, so as I mentioned before, I am recording these sessions. This is for our first meeting for Boyce 110 nursing students, but if anyone else is in here for any other nursing, you're welcome to join along. If at any point you have questions, just please feel free to ask. If you don't feel comfortable asking, you can, by putting yourself off of mute, you can always send it into the chat. You can send it as a direct message and I won't identify who said it, or you can also email me. So go ahead, you can ask your question.
Yeah, you said that we should have access to the share drive.
Is it Janelle?
Yes, it's Janelle. I'm sorry. Yes. Hi. You said we should have access to the
Hold
share.
on one second. I don't hear you, so let me see if that's my volume.
Yeah, I can hear her. So
Can you hear me now?
I think that his volume.
I'm sorry. Go ahead. I had to switch my speaker output, so I should be good now.
Okay, can you hear me now?
I can hear you now.
Perfect. Hi, yes, I'm Janelle. Hi. I was just wondering, you said that we should have access to a shared drive. I don't see that in the folder. Only thing I see is the dosage practice, or is that what you're talking about?
Yeah, it's a folder that has practice material in it for
Okay.
yeah, yep. And
I
so
wasn't sure if it was like another drive or something. That's all. Okay, cool.
Okay, no. Everything will be posted in that one area.
Okay, thank you.
You're welcome. Good question. Okay, so now that I can hear people, and thanks for raising your hand, I did see that. So the first thing I want to do to kind of get things started here is outline the blueprint and what to expect on this test. So one of the things that you need to know about this class or this test is it's 25 questions. You can miss 2 and pass. If you miss more than 2, so if you miss 3 or more, then you're going to have to go through remediation and take the test again. And if you miss it the second time around, then they're going to disenroll you from 110 and you're going to have to basically play catch up next semester. So there is some importance on this test, but thankfully there's practice, there's reviews. If you feel comfortable with math, which I know most nursing students do not feel comfortable with math, but if you do, then this test isn't that difficult. If you just need a refresher, that's what I'm here to help you out with. And I'm going to kind of walk you through what you need to know. So I wanted to first just briefly go through the blueprint, what to expect. And then I have a few practice problems I want to go through with you as well. And then we'll address any questions for this first session. And we'll start working together over the next couple of weeks, because we have several times that you'll potentially be able to come on. You're, at least to my knowledge, you're not required to come to all these. I imagine there's more than 8 students or 7 students in your 110 class. So anything I share in here, please share with them. This is not supposed to be private information. It's just supposed to help you so you do well on this test and then future tests moving forward. And then just for in addition, this should also help out with your ATI. If you ever come across questions on ATI that you want to go over during these review sessions, I'm happy to go over them with you. And it should also help you out with your NCLEX, but obviously you don't need to worry about that for a couple semesters. So when you are solving questions, first of all, you need to make sure that you are labeling your answers correctly. And by that, what we mean is, in scientific terms or in the sciences, numbers have meaning. So it's not just 5. Sometimes in the sciences, you'll hear somebody say 5 what? And so they mean 5 milligrams, 5 milliliters, 5 tablets, 5 units. make sure you put the correct label associated with what you're calculating. Some of the questions you're going to get asked will not be as direct or as intuitive as, oh, okay, they're looking for milliliters. I will go over some examples of that next time. But for today, we'll kind of go through some basic examples that are like basic unit conversion type things that shouldn't be a problem for you, but you won't have to wonder what they're looking for. And then later on, and especially when you get into like 130, 220, 230, 240, there is more of a challenge and just, well, what are we looking for? And I'll help navigate and I'll show you some of that stuff, even though it won't necessarily be on your 110, but you can always come back to this. Because like I said, this will be available to you on YouTube and you can always come back to it another time if you want to. So zeros, when it comes to using zeros, you want to make sure you're not overusing or underusing your zeros. So you do use a leading zero when you have something that's less than 1. So the example given here is 1 milliliter. If 1 milliliter is the example, that would be that's fine as it's written. But if it was half a milliliter, you would want to write 0.5 and make sure your decimal point is clearly delineated. The presence of the 0 being there should also indicate to your instructor or whomever is grading your test that that is a decimal answer. So if you meant to put 5 milliliters, you should never have a leading 0 for 5. Like you don't need to have 0.5 milliliters. It would just be 5. But for numbers less than 1, 0 point whatever that number is the appropriate way to write that. And then you do not want to use trailing zeros. So as we said in the previous thing, 0.5 is correct, but you wouldn't want to write 0.50. And the reason for this, and it may make sense to most of you, is that what you don't want to do and what you're trying to eliminate is the possibility of thinking that this is a like the answer is 50. Even though clearly you can see it's 0.5 milliliters, you don't want someone thinking that you unintentionally wrote 50 or 500 or however many zeros. So you don't need to put the zeros after your answer, but if it's less than 1, make sure you have a 0 before your answer. That's also why this 1 milliliter, it just says 1 milliliter, it doesn't say 1.0, because when you're writing that out quickly, then that might get misconstrued as 10. And we're trying to avoid that confusion, the potential confusion. All right, what about rounding? So there's a couple of rounding rules that you'll see discussed multiple times throughout these review sessions and talked about. And when rounding in nursing, it gets a little bit tricky as far as what population we're talking about. So the rounding rules for the general population adults, when we're talking about medications, these rules typically apply. When you get into 3rd semester nursing and you are doing more of the pediatric dosages, you're going to have slightly altered rounding rules, because you wouldn't want to round incorrectly, especially if you have like a newborn or a preemie or something like that. You want to make sure that the recommended dosages are applicable to the size of your patient, essentially. And then these rounding rules would also vary from other professions as well, but we're talking about nursing, so we're going to leave it as that. So when you have a volume that is greater than 1 milliliter, so this is in regards to milliliters, you should calculate your answer should be calculated out, basically. It does say calculate to the hundredths place, but what they mean by that is like just type it into your calculator or type and get an answer. So if it ends up being greater than the hundredths place, that's perfectly fine, but you're going to use the hundredths place as your indicator for your rounding at the tenths place. So what do I mean by that? So let's say you get an answer that is 1.25 milliliters. You're going to look at the 5, which is in the hundredth place, And then that 5, if it's 5 or greater, you're going to round the number in the tenths place up. If it's 4 or fewer, you're going to leave it alone. So if it's 1.25 milliliters, you're going to round up your answer to 1.3 milliliters. If it were 1.24, so again, we're looking at the hundredths place here. The hundredths place is what tells us what to do with this number here. And since it's 4 or fewer, we would say 1.2 milliliters is the correct answer. Now, when you have volumes less than 1 milliliter, then you're going to take it down to the next position. So essentially what you're looking for is you want to have 2 significant figures to 2 significant numbers when 2 significant numbers are plausible or possible. So as an example, we have an answer of 0.969 milliliters. We are not going to just look at the 6 here. We're actually going to take a step back into the thousandths place, and we're going to look at the 9. And then that 9 is going to tell me what to do to the hundredths place. So in this example, number or volumes less than 1, you're going to round to the nearest hundredth place. So this answer would be 0.97 milliliters because the 9 obviously greater than 5. In the subsequent example, 0.963 or 0.963, we're going to look at the 3. The 3 says to leave the 6 alone, so we'd leave our answer at 0.96. Are there syringes that go down to the thousandths place? Yes. So ultimately, it depends on the syringe that you have available. That will also be the thing that dictates your rounding and also the different types of medications that you're utilizing. I will say from experience teaching this, at least for the nursing students at Allegheny and at Boyce, we usually don't even deal with this. It usually ends in the hundredth place. You just need to remember to leave it alone. So if you get an answer of like 0.75, that's your answer. Don't change that to 0.8. And then that's just a matter of following the rounding rules for volumes less than 1 milliliter. All right, military time, we'll talk about that, but if they tell you to give you a time, that you usually will ask it in military time. So you might need to do a Google search just to review your military time if you're not familiar. Midnight is 0, and then it goes 0, 100, 0, 200, 0300, 0400, 05, 06, 07, 08, 09, 12, and then it goes 1300, 1400. So that's 1 o'clock, 2 o'clock, 1500 is 3 o'clock, 1600 is 4 o'clock, 1700 is 5 o'clock, 1800, 19, 20, 21, 22, 23. So it's just a 24-hour representation of time. So sometimes you'll see a question that says you start an IV at 1200 hours, and it's it's a 500 milliliter IV. It's going to infuse at 100 milliliters per hour. What time will it finish, in military time? So, and then you would do some calculations and you'd like say, oh, okay, it'll end at 1700 hours. We'll go through examples of that as needed, but that shouldn't be a problem for most of you. Couple other tidbits here. When calculating medications, note the dosage available to give and the mechanism which it is delivered, such as using a 1 milliliter syringe medication, meaning it can be set to the hundredths place, as we discussed before. But you may also deliver, you might see that things are available in 3 milliliter, 5 milliliter, and even 10 milliliter syringes. So if it is a 3, 5, or 10, then you would round your answer to the nearest tenth. If it is a 1 milliliter syringe, those syringes typically will be you can round to the hundredths place because you will see that as an example. And what I mean by is, and I'll pull up pictures and I'll make a note of that so I don't forget. So you can see what some of these look like. But you'll see syringe images that have the different numbers denoted on it. And I'll show you how to kind of understand that a little bit better. All right. So your 25 questions for Nursing 110 are going to be broken down into these categories. The first 5 questions that you'll see will be what are considered your household measurements, as well as converting between systems, meaning converting between the metric system and then household units. Additionally, kind of hand in hand with those, you're going to see some metric unit conversions going from like kilograms to grams, milligrams to grams, milligrams to micrograms, as well as weight-based conversions going from pounds to kilograms. So your first 8 questions on your test are going to be your basic, I say basic, but your basic unit conversions. I'm going to show you what's called dimensional analysis. And if you had chemistry or another class and you're like, I hate that thing, I'm going to show it to you just as a method. But if you have other ways that you're doing it, then you can do your way, and that's perfectly fine. Don't feel like you need to follow what I'm doing. As long as you're getting the right answers, then you're doing it right. There's no one way to do these questions correctly. Just make sure you're showing your work, and make sure you're getting the answers right every time you do it. We will discuss some intake and output calculations. We'll do those next week. Intake and output, meaning how do you calculate volume of what your patient might consume while in the hospital, and you want to know how much fluid they've brought in. And then I'll also give you some output calculations, meaning that let's say you want to make sure that your patient is staying hydrated. How much fluids do they need to be replaced with when they void after a certain period of time? So we'll talk about that. Then we'll get into these calculation of oral meds. These are pretty straightforward. You're going to see these and you're going to think you're a rock star with dosage calculations, and most of you will be, because it's going to be things like you're ordered, the order is 500 milligrams. It's available in a 250 milligram per tablet, and then you would give them 2 tablets. And so conceptually that'll make sense, but we'll talk about it and work through those in the coming weeks. Then we'll talk about the parenteral medications, so subcutaneous, intramuscular routes. So anytime, and you'll hear me say this again, anytime you see sub-Q, IM, or even IV, you already know that your answer is going to be in milliliters or in cc's, but usually it's milliliters. And the reason I say that is because these are your injectables. We can't inject powder, and we can't inject, you can't easily inject powder, and you can't easily inject like full tablets and capsules. Okay, those are meant to be swallowed. So subcutaneous, intramuscular, intravenous, that means it's going to be in a liquid form as an injectable. So that helps you out. So if it ever says like calculate what you would administer for this blah 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 intramuscular, then you know your answer is going to be in milliliters as a result of that. And you'll hear me say that when we go through some of the examples. Now, if you go through the practice tests and you look at Allegheny campus practice tests, you'll notice that they have more of the Allegheny campus, they get asked like, what is, the milliliters, what is the tablets, so each campus does that a little bit differently. So I just want you to be prepared, and I will make sure you're prepared for that, because when you see some of the examples, it'll seem simple, but you want to make sure you can answer that question even if it wasn't given to you. Then we'll talk about reconstitution. Reconstitution is a specific type of medication where typically it's in a powdered form in the pharmacy. The pharmacy will add, per the instructions on the label, they'll add deionized water typically, or distilled or sterile water to the medication. And then the tricky part, and we'll talk about label reading and things like that. The tricky part with the reconstitution of medications, or the reconstitution problems, is that you have to look into the label to decipher what is the strength of this medication. So we're going to go over that, and we'll cover that in depth. And then we'll talk about insulin dosages. This is pretty straightforward. This is just, can you read the scale as it's written, and can you determine how much insulin you administer to a patient or client based off of the information there. So it'll say, like, if their blood sugar is 200 and it'll show different ranges, you would give them 2 units of insulin. And then, so there's really no math. It's just, can you read the information? So, all right. Any questions on the blueprint? And then for some of you that came in after I started talking, I just want to let you know this will be posted on YouTube. I will also share a link to these. So whether you can come every time or not, it will be, I'll make it available to you. I put my email address in the chat just in case if you need access to the practice problems, and that way you can, I can email it to you if you didn't get it already, but you should have access to it. It's just it's a link to a Microsoft OneDrive folder, and that Microsoft OneDrive folder has practice tests for you guys. All right. So what I'm going to do now is switch over to some practice problems here. So the first few problems that you'll see associated with your dosage calc test is going to be these household and metric unit conversions. And so what I've done is, and this is from, it's in the Allegheny campus folder, the 110 practice set. So this is just the practice set. So it's not it's just a group of numbers, and I'm going to create some additional practice for you because I think you're going to need it a little bit more catered and specific for you at Boyce. So you're going to see some unit conversions. We're staying in the metric system. So here we're going from milligrams to grams. Then we're going to go from micrograms to milligrams, and we're going to talk about all that. Then we have going from household units, pound, to metric, kilograms. Again, pounds to kilograms. Again, pounds to kilograms. So some practice there. Then we're going to go from metric, milliliters, to household ounces. Milliliters to liters, so that's metric to metric. Milliliters to teaspoons, so that's metric to household. Then we'll do household tablespoons to milliliters, ounces to milliliters, so household to metric. And then these, if you're looking at these, you're like, I got this, this is pretty straightforward. Good. Then going through the samples or the examples of this should be helpful and help you to anchor and understand and have a better retention on this material. So I'm going to go ahead and turn on my screen here. And then you should be able to, Here we go. You should be able to double click on my screen, and then that should give you a better view, or so you can zoom in. But if you come back and watch the recording, you'll see this specifically on there. So the first question that I put together was the 1500 milligrams. And we want to know how many grams that is. Okay. Now, a couple of housekeeping things. You need to know some basic unit conversions. So I didn't pull this up, but I'll make sure to pull this up the next time we get together. And I'll just focus on these things. But I did put together a list of some common household and metric unit conversions. I do need to put together a few more household conversions, because you guys need to know how to go from like quarts and pints to ounces and then eventually to milliliters. And I'll put those all together for you. So the first thing you need to know is that 1 gram is equal to 1,000 milligrams. Okay. So in order to solve this problem, you need to know either A, how to move a decimal point over to the correct area, or at least know your basic unit conversion, which is 1 gram is equal to 1,000 milligrams. Once we know that, then I can set up and do dimensional analysis for this question. Whether you like dimensional analysis or not, that's what I'm going to show you. And then I'll also show you the alternative ways that I would do this particular problem. So using dimensional analysis, I'm going to start off by writing 1,500 milligrams. Some people like to write it over 1. You don't have to, but if it makes some of you feel better, I will. 1,500 milligrams, then we're going to multiply by our conversion. And what we're doing is, and one of the reasons why I like to show dimensional analysis is because if you're ever stuck with doing science-based math, dimensional analysis can be the thing that gets you out of the woods, because it'll give you a plan of action that you may not have otherwise thought of to do before doing it. So it is a practice. It becomes a skill that you can learn, but it does take practice doing that. If you have always done or have heard of doing what's called ordered over half, that's great. That works for 90% of the math problems that you'll have throughout your nursing education. But that 10% sometimes falls on your some of your semesters in which, if you miss that 10% of understanding where the ordered over half doesn't work and you don't have another strategy, then that could mean remediating, retaking that particular test. And I want to try and prevent you from doing that, right? You just take it the one time so you can just worry about the other stuff you have to study for. So the strategy is this. Typically, when you're doing something like this, you know where you're starting, milligrams, and you know where you're going, grams. And so all I'm going to do is use that information to create a conversion. So I don't want milligrams. So that's why I started with milligrams. I'm going to put milligrams here in the denominator because I don't want it. So I'm trying to cancel it out. And you can't just put anything up here. You need to know what conversions you have. So that's why I've written that down there. So we know that 1 gram is 1,000 milligrams. So if you've ever done this on a test, and we all have, you had convert 1,500 milligrams to grams, and you wrote 15, you wrote 1 point, or what is it, 15, or 150,000. And you're like, did I get it right? Or 1.5 million. Like, did I get it right? No, because you put your, you brought your, you moved your decimal point to the wrong place. And then sometimes you guess going in the wrong direction, going in the opposite direction, and you're like, well, which way is it? So if you do this a couple of times, you'll always remember. The other thing is, notice that 1 gram is 1,000 milligrams. So it takes more milligrams to equal a gram. So if this is 1,500 milligrams, then it's not going to be 15,000 grams, right? It's going to be a smaller number because of the conversion. So you plug this into your calculator and you will get 1.5 grams. Notice I didn't put 1.500 grams because we don't use the leading zeros. Okay, so that's dimensional analysis for this problem. For me, when I do this problem, what I do is I take that 1,500 milligrams, and I know that I have a decimal point sitting there at the end of the 1,500. I'm going to move my decimal 1, 2, 3 places to the left to give me the 1.5 grams. So if you're somebody who does it this way, you're doing it right. But if sometimes you move the decimal the wrong direction and you get hung up on which way to go, then I just want you to know, like, there's a strategy for that. So just make sure you practice. Go ahead, Shane.
Thank you. You don't need to show work as long as you get the right answer, right?
They want you to show your work.
Oh, shoot. Okay. Thank you.
You're welcome. Now, as far as what you need to show, that is not quite clear, at least not to me. Meaning that, you know, they're probably going to be less concerned about what kind of work you show for these basic unit conversions, and more so concerned about the work that you show for coming up with how you administer the medications and things like that. So my recommendation for you is to write something down. I think the more important thing is just that they're getting that information, that they're seeing that you work through the problem, and that shouldn't be a problem. So if you knew like instinctively, like, oh, it's 1.5 grams, this is pretty simple and straightforward, perfect, great. But make sure when you do this, just indicate something, just move your decimal, or put something, just indicate it somehow.
Let's put like 1500 over like 1000, like divided by 1000 equals 1.5, done.
You can do that way as well. Yes.
Cool. Thank you.
Yep. You're welcome. Now, this is something that you're probably likely to see, and I want to show this to you as well. Let's say you had 1,275 milligrams, and we want to know how many grams that is. I'm going to do the move the decimal point over, and the answer for this is 1.275 grams. Do not round your basic unit conversions. Like if you're going metric to metric, don't round that. If you're going household to household, don't round that unless you're told to round that. What this is just kind of doing math. So even though this breaks the rule and you're like, no, I want to write 1.3, do not write 1.3. So do not round these. Okay. This is very, very specific for these sets of problems. Okay. When we go from pounds to kilograms, we're going to round, but that's because we're going from household to metric. That's why we round. But when we're going metric to metric, do not round. When we're going household to household, most likely you're not going to need to round.
Will the problem state whether we're supposed to round or not?
It will not. You need to know whether or not to round, and that's why you'll hear me go through and I will repeat the rounding rules, but make sure you're reviewing them on the blueprint. This is something that the only reason I'm bringing this up is because more often than not, students I've worked with remediation wise that didn't pass the test, it wasn't because of the math, it was because of the formalities. And this is one of the things that technically is correct. You don't round when you're just doing basic unit conversions, but when you're constantly being told, make sure you round, don't forget your rounding rules, you get conditioned to round these things when you're not supposed to. So that's why I'm telling you, when you're going metric to metric, so when I go metric to metric, and then this should apply, and I'll let you know if this isn't, and if I go household to household units, do not round. Do not round those basic conversions. This is also why I go through these first, to show you and remind you, because there are some nuances to rounding. Wait till you start learning about drops, and then you'll be like, wait, what? Oh, we're not supposed to round a drop? Nope, you can't round drops because you can't give a partial drop, but you'll talk about those starting next semester. All right, the next question was just another unit correction or question here, and I'm just going to write down the next two. So 250 micrograms is how many milligrams? And then the next question is the 165 pounds is how many kilograms? And then the next question after that is 117 pounds equals how many kilograms? And then the last one is the 182 pounds. How many kilograms? Okay. So don't worry, I'll make sure that you can see all these things. So just like last time, I need to know what my conversion is for micrograms to milligrams. So that conversion is 1 milligram equals 1,000 micrograms. Now, sometimes you'll see micrograms written out like this. It's a Greek letter mu. So you'll see it written out where it looks like a U or a funky M. You don't need to worry about that too much. I haven't really seen that too much, but you might see it on a drug label. So there's two ways that micrograms can be represented. In traditional sciences like chemistry, physics, things like that, usually in your textbooks, you'll see it written like this, but in medicine, we typically see it written as MCG. All right, so I can do this one of two ways. I can move my decimal 3 to the left if I want to do it that way. And if you don't feel comfortable doing it that way, you can just write it out as a conversion, 250 micrograms. What do I want? Well, I want milligrams. And then I'm trying to get rid of micrograms. And do I have a way to convert milligrams and micrograms? I do. 1,000 micrograms and 1 milligram. The other thing that I'm trying to role model is that I put my units first before I put my numbers. And again, this is more so for you if you are someone who kind of makes the mistake of forgetting, am I multiplying or dividing by 1,000, or do I move it to the left or to the right? This is a strategy just to kind of help anchor which way to go with the information. And then my answer is going to be leading 0, 0.25 milligrams. So get rid of the lagging 0. You don't need it, or trailing 0. You don't need that. 0.25 is your answer. All right, let's look at these pounds to kilograms. And don't worry, we're going to come back. We'll do additional practice things like this. If you feel like you got it, good. If you feel like, you want to see some more, we have plenty of time throughout this semester over the next couple of weeks. I'll be working with you Tuesdays and Thursdays for the most part, and we'll get through this together. I mentioned this earlier too. If you do have a question that you want to see worked out, and for whatever reason you can't be on the Zoom meeting, just email me and I will work through a particular problem. If you could send a screenshot, like if you're working on an ATI problem that you need help with, send a screenshot. I need to see the problem. Trying to describe a problem, sometimes it gets a little bit challenging to see what the question is asking, and then I will give you my my 2 cents on how to work that problem out. All right, so we need to know another conversion. So the conversion for this is 1 kilogram is equal to 2.2 pounds. So that's the standard. So anytime you're going from pounds to kilograms, you're dividing by 2.2. Okay, so that's the short version of it. So I'll still show you the dimensional analysis just because I think it's good practice. But if you just take this number, divide by 2.2, you're doing everything right. So let's look at this. I'm going to take the 165 pounds. I don't want pounds. I want kilograms. I know that looks like a 16, but it's supposed to be an L and a B. 2.2 pounds 1 kilogram. Now this, we're going to need our calculator. So you can use, if you don't have a calculator, you can always use the one on your phone, or you can use the one on your computer. And so what I'm using the one on my phone. 165 divided by 2.2 is a whole number, 75 kilograms. So that's it. You don't have to worry about rounding or anything like that. Your answer is 75. Going to do the same thing here. Because it's the same setup, I won't show it again. I'm just going to go ahead and divide by 2.2. And then I'll write that here just so you know what I'm doing. So 117 divided by 2.2 gives me 53.18181818, and it just keeps repeating. Okay, so what we're going to do is now we have to apply our rounding rules. I'm going to round this number to the nearest 10th because it's a number greater than 1. So 53 point, and I'm going to look at the 8. The 8 is greater than 5. So I'm going to round this to 53.2. So if you wrote that down, if that's what you put as your answer, if you were doing this ahead of me, then you did that correctly. 53.2 kilograms. And then lastly, the 182 pounds. So I'm going to divide by 2.2 again, and I'm going to get another decimal answer, 82.727272. So it just keeps repeating. So again, I'm going to round that number. I'm going to round that number to the nearest 10th because it's a number greater than 1. And I'm going to look at the 100th place. The 100th place is 2, which is less than 5. So we're going to leave it as 82.7. 82.7. So like I said, usually, and maybe you'll get lucky, maybe your test will say round your answer, but I would just be prepared that you're not going to be told when to round. You just need to know. And that's part of what these review sessions are going to help to illuminate for you, is when to do certain things and when not to do certain things. But notice we went from household to metric, which is why we would round. And as a reminder, when you're going from metric to metric or household to household, do not round those answers. Okay, leave them unrounded. And then another telltale sign is if you have this whole run on like 1.3535353535, that's a good indication that you need to round. And usually you're not going to see that when you're going within the same system, metric to metric or household to household. All right, let's look at some other problems here. Let me get a clean sheet. And let me pull up my screen here. All right, so some more things like this. So 200 milliliters is how many ounces? Then we have 350 milliliters is how many liters? And then 30 milliliters is how many teaspoons? Two and a half tablespoons is how many milliliters? And finally, 1.5 ounces is how many milliliters. All right. So again, there's some basic unit conversions that are helpful to know. And while I'm thinking about it, let me see if I can pull those up real quick, just so you know. Maybe we can look at that together real quick. There we go.
I have a question.
Go ahead.
Whenever we're taking the test, there's not going to be any conversion, like it's not going to tell us any of that, correct? Like with the
Correct.
pounds to kilograms. Okay.
Yeah, you have to know it.
Okay.
So that's not what I want to share. So give me 1 second. I'm going to show you what that would look like. So
Okay.
this is a sampling, and there's a few more that I'm going to add in. So if you go into where the practice tests are for Allegheny campus, it says no dosage calc review intro, and that form gives you all these things. But this is basically the conversions that you need to know for taking your test. So we already went over grams, milligrams, milligrams to micrograms. We're going to, in a little bit, do liters to milliliters. Then you can see kilograms to pounds. And then here's some of the other ones: a teaspoon, a tablespoon, an ounce, and then of course an hour. I'm going to add some more to these because for Boyce, you also need to know more of the household unit conversions like pints and quarts and things like that. And so I'm going to make sure I get those straightened out for you guys. So, but that's what that is. Oh, and I should also add that when we talk about ounces, we're talking about fluid ounces. Because obviously you probably know that 1 pound of something, a solid something, is 16 ounces. And so that is obviously different than what is fluid ounces, whereas 8 ounces is 1 cup. And so some of these things you start to wonder, it's like, why in the world are we using the household system when the metric system seems to address all that stuff? And then I don't know, you probably have to talk to your senator or something about it. But here is the basic unit conversions and where these are coming from. And then, like I said, I will put together an added list of this, and I'll post it in the Boyce 110, the Boyce folder, which is in the Microsoft OneDrive shared folder. Okay, so as I mentioned before, milliliters to ounces. So 1 ounce is the same thing as 30 milliliters. And again, like what you were just asking, you do need to know what that is. There's not going to be like a table sitting beside there on your test. It's just going to be answer the questions. And so you're going to have to know that. So the way I would set this up using dimensional analysis is I would take my 200 milliliters. I would over 1. And then I would do this to do the conversion. So I'd have 200 milliliters over ounces. I look at my conversion, 1 ounce, 30 milliliters. So now you know you're going to be dividing. Okay. So I'm going to take 200 divided by 30. And that's going to give me 6.66, and that's repeating. So I'm going to round my answer because I'm going from metric to household. That's why it's okay to round to 6.7 ounces. And that's an OZ. That's the abbreviation for ounces. If you prefer to just write ounces, that's perfectly fine. Milliliters to liters. 1 liter equals 1,000 milliliters. So this looks a lot like our conversions that we saw associated with the milligrams and grams. And that's because that's exactly what that is. a gram is the base unit for weight. A milligram is a 1,000th of that weight. A micro is 100,000 of that weight. A nano, or maybe that's 1 million. I'm sorry, 1 million of that. And then it goes down to nanogram and it keeps going up, or you can go up to like decigrams, and you may have heard of centigrams and things like that, which we don't usually talk about. We usually talk about centimeters and millimeters and decimeters and things like that. But the ones I'm showing you are the common ones, which is why you don't necessarily have to rehash all of your, your base 10 metric system numbers like you may have done in biology or even in chemistry. You just need to know some of the common ones that are frequently used in the nursing program. So I'm going to take my 350 milliliters. I don't want milliliters. I do want liters. And I know that 1 liter is 1,000 milliliters. And that will help me out with knowing which way to move my decimal. And my answer would be 0.35 liters. Don't round. That's your answer. If that number were 1.375, don't round. That's your answer. When you're going metric to metric, don't round. That's your answer. Teaspoons. Sometimes you'll see teaspoon abbreviated as a little t. And then sometimes you'll see tablespoons abbreviated as a big T. So I put those in parentheses just as a, just in case you see that. Okay. So 1 teaspoon is equal to 5 ml. And if you don't believe me, the next time you do any kind of cooking and you happen to use a teaspoon or a tablespoon, you'll see it written on there. And so you'll at least know that that something in your life is like coordinated to what you're learning here in nursing. And then tablespoon is equal to 15 milliliters. So guess how many teaspoons equal a tablespoon? 3. 3 teaspoons equal a tablespoon. And 2 tablespoons equal an ounce. So some of this starts to come together, which is sometimes kind of fun. All right, so for going from milliliters to teaspoons, I'm just going to write that down here. 30 milliliters. I don't want milliliters, I want teaspoons. So I'm just going to abbreviate that little t. 1 teaspoon is 5 milliliters. So 30 divided by 5 would be 6 teaspoons, or 2 tablespoons, or 1 ounce, depending on what they're asking or what you're converting. Tablespoons to milliliters. This is 2.5. I'm just going to write big T. And again, I don't want big T, I want milliliters. So 1 tablespoon is equivalent to 15 milliliters. So this time we're not going to divide our answer. We're going to multiply 2.5 times 15. 2.5 times 15 gives me 37.5 milliliters. And then last, this is a reverse of the first one we did, the 200 milliliters to ounces. Now it says we have 1.5 ounces to milliliters. I'm going to take my 1.5 ounce. Again, I don't want ounce, I want milliliters. And I know that 1 ounce is equivalent to 30 milliliters. So 1.5 times 30 is 45 milliliters. So a lot of this in the beginning here is just kind of getting an idea of where to start, as good as it might be watching me do the math, it's going to be infinitely more beneficial if you do these problems, even if they're simple. Just practicing your setups, at least for in the beginning here, we'll keep it simple and just, spend 5-10 minutes just kind of practicing these problems again, just the just a few problems, or if you've had enough for today, that's perfectly fine. And you can just rewrite what I had put up there. And like I said, I will post this up and give your instructor the Zoom link. I will also make this available on my YouTube channel. I'll create a playlist for Boyce 110, and I'll even say for the spring or fall 22 semester. And then the next time I'm scheduled to meet up with you guys would be next week on Tuesday at 2:30. And I think this will be a great place to stop. If you have any other questions, just let me know. And if not, I will see you next week.
Thank you.
Thank you.
You're welcome.
Thank you.
Thanks a lot.
Absolutely. You're welcome.